Hello everyone and welcome to another Würth Elektronik ISOS webinar. My name is Markus Eberle and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's webinar is everything you need to know about sensing humidity in the atmosphere. Our speaker today is Vinod Ramu, who is working as product manager in the field of sensor components at Würth Elektronik ISOS. He will hold today's webinar and also answer your questions. Before we start the webinar, I would like to point out one thing. You will be muted during the webinar today. This means that you cannot ask us questions via microphone during the webinar. Nevertheless, you have the opportunity to ask us questions during the webinar at any time via the chat function. You will find the chat function in the webinar control panel. Today's webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. There are 10 to 15 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email after the webinar. And if you still have any other questions left after the webinar, just email us at isos-webinar@we-online.com. At the end of the webinar, you will be asked to participate in a feedback survey. Of course, we would be pleased if you take the time to fill out the survey and help us to improve our webinars. You will also receive the link to the presentation as well as to the recording of today's webinar only in the next few days. And now I will hand over to our speaker, Vinod, and I wish you an exciting webinar.
Thank you for the introduction, Marcos. And thank you for the listeners who like to participate in this webinar session. So for today's webinar, here's the agenda. I would like to give a short introduction about humidity in general, why it is important, and what are the applications where humidity is important to monitor or sense. And I would like to show the available humidity sensor with an integrated temperature sensor package of VSEN HIDS series from Vert Electronics. And I also like to give some guidelines or suggestions of how to handle humidity sensor. In simple to say, handle with care. So what is humidity? Here are many examples of humidity and how it is playing a vital role in these use cases. For example, in our planet, if there are no water molecules present in the atmosphere, by default or by meaning it's minus 15 degrees Celsius without water vapor. So if there are no humidity present in the atmosphere, the temperature of Earth is minus 15 degrees Celsius. Similarly, humidity also plays very important role in certain animals. For example, the dogs. If the humidity is more than 65% present in the atmosphere, it's really not good for the dogs where it cannot sweat easily in the high humid environment. So that is why it is advisable not to take a dog with you during jogging or walking in a high humid environment or cities. And another interesting application where humidity plays an vital role is indoor air quality or indoor climate monitoring, where for humans the comfortness of the humidity and temperature is defined. So for example, for the temperature, it should be around 20 to 25 degrees Celsius max, and also the humidity range from 30 degrees Celsius to 60 degree the relative humidity percentage. Another important place where humidity is concerned is where mold is forming in our home. For example, if the humidity level in our home is more than 60%, then there will be a rapid growth in the formation of molds. So that's why it is advisable to monitor the humidity level during winter times to check a frequent ventilation times. And one more important use case is where the virus gets active with the humidity, meaning the virus or bacteria usually cannot survive or cannot be active in the range of 40% to 60% relative humidity. As we saw, humidity is a very important parameter to be monitored or sensed, and also it's important to see how to interpret the humidity or represent the humidity. So humidity could be either absolute or relative. Here, the relative meaning is the humidity parameter is relative to the temperature present in the atmosphere. Here are the two examples how the relative humidity is different from two different cities with respect to the temperature. In the first example, in this case as a Berlin, the temperature is 26 degrees Celsius, but the humidity is 41%. And then second example here with a humidity of 80% and 14 degrees Celsius in Dublin. If we have to ask where exactly one could feel more humid among these two cities, one can say by looking into the parameter of humidity in Dublin, which is 80% more than Berlin. But actually, since it's relative to temperature, the more humid you feel, actually it's in the Berlin, not in the Dublin. Let's get started where exactly the humidity monitoring or sensing is important or plays a key role. Here in this use case, I would like to show some important aspects of smart farming where humidity sensing is very important. For example, by cultivating or farming strawberries or any form of berries, it is very important to monitor temperature, gas, and humidity, because all these three or four many parameters will play a very important role in the yield of the fruits or berries or any other vegetables. How does it work? The monitoring system has many different sensors, which is placed close to the plants or crops, what you could see in the picture too. So all these parameters like humidity, temperature, solar radiation in the form of UV light, and also CO2 gas are monitored constantly, and it's communicated to the farmer through many IoT technologies. Here in this example, the farmer will get a notification if there are any possible disease might affect the crops because of very abnormal humidity, temperature, and CO2 gases. As we know that the close controlled farming is getting a hype now, and there are many manufacturers who test various products in order to support these kind of activities. Monitoring active humidity and temperature plays a very important role in vertical farming applications. Another important place or application where humidity sensing is predominantly needed is in HVAC products, meaning heating, ventilation, and air conditioning systems. Here in this example, it's a simple HVAC system where outside air is sucked in and then it's filtered through many filtering steps at the end, and new set temperature and humidity values or parameters incorporated, so the air what we get out from the HVAC will be fed into the inside room with a certain temperature and humidity values. As this could be affected due to rapid change in the humidity or temperature outside the building, so there is an important place where humidity and temperature sensor could be implemented in order to achieve an effective performance from HVAC systems. As we know, these HVAC systems are quite common in commercial malls. So most of the commercial malls should be having a HVAC systems. And also in many office buildings where the ventilation is actively monitored or actively fed through HVAC systems. And similarly with the cinemas and theaters. what happens if there's no active humidity temperature sensing in the HVAC system for a controlled or closed loop system, or what happens if a HVAC system is completely switched off. Let's see what happens. Here is an example of what happens when there is no controlled HVAC or the HVAC is switched off. During COVID, there are many lockdowns happened in many different countries. Here is an example of a lockdown happened in Malaysia, where the goods or the products which are made of leather or sensitive material was completely destroyed due to high humid present in the environment. So what happened in this lockdown? So the HVAC system was completely switched off. So the outside air has an average of 80% relative humidity in cities like Kuala Lumpur and in Singapore. So where the malls needs to be actively monitoring the humidity and temperature inside the mall with inside shops. Since the system was completely turned off, there was so much humid formed on surface of the materials here in case of leather shoes and leather products and also some cloth. Over the course of time, slowly the mold has formed. So all the products were not usable. So these products are completely destroyed because of no controlled HVAC or no active humidity and temperature monitoring in the mall. And here is also an interesting example of what happened in also a cinema theaters or movie theaters in Malaysia. It also happened due to no controlled HVAC systems or no active monitoring of humidity and temperatures. So now they have to remove all the seats and then place a new seats, just because they didn't place a small system where it could monitor temperature and humidity and alert the necessary people to do something. Here is an example of active humidity temperature monitoring in warehouses, where the storage condition is a key parameter or key conditions to store certain products in certain levels. For example, the pharma products has a certain storage conditions. In order to use any warehouse to store pharma products, the temperature and humidity should not exceed the certain level. So here in this case, the temperature is 15 to 20 degrees Celsius and humidity of less than 60%. Similarly, the electronic products, so all the electronic products which could be stored in a warehouse needs to be maintained with a certain temperature and humidity levels. In this case, it's a 40 degrees Celsius, so the warehouse should never have a higher temperature range, and also the humidity of less than 90%. Most of the European countries, it's easy to maintain these parameters in summer, but it's difficult to maintain these parameters in winter. But similarly, in Asian countries, it's difficult to maintain a lower humidity range of less than 90% within a lower temperature range of 40 degrees Celsius. There are many other products where sensing humidity and temperature in the warehouse is also important. For example, furniture or any showcase materials which is made of wood. Here, temperature and humidity plays a very important role in storing those products. And also, not to forget the food products, what needs to be actively monitored with the temperature and humidity, where it's very predominantly sensitive to temperature, which needs to be kept in freezer. So during COVID times, there are many lockdowns and many warehouses were completely shut down or not used in day-to-day basis. So many of the food products got destroyed because they didn't have any controlled or active monitoring of humidity and temperature to store certain food products. So as we can see, sensing in humidity and temperature is very, very important in storing, not only using the products and also storing some new products. So the last use case I would like to talk about is indoor climate monitoring or indoor air quality monitoring, where humidity and temperature is very important to sense, as we saw on the previous slide, to avoid mold and also to have a comfort feeling in our home. So every room has a different level or parameters to be maintained for humidity and temperature. So this can be actively monitored using a monitoring system which could be connected to a Wi-Fi, and we can easily control the heating through smartphone. So all this controlling system, the front end of the whole controlling system, comes from humidity and temperature sensor. Another interesting place where active humidity and temperature monitoring is predominant is in the museums. Here is an example of Mona Lisa painting in a museum from France, where active humidity and temperature sensors are already incorporated inside the viewing window where the painting is placed. So in this case, the temperature and humidity is actively monitored even with an update rate of less than 1 Hertz, meaning so the system which controls the climate in the viewing window reads the value from humidity and temperature in more than 1 second, and the system should maintain the humidity on 50% and temperature of 21 degrees Celsius. At the end, I like to show there are many use cases or many applications for indoor climate monitoring. Another interesting place where monitoring humidity and temperature is important is schools and lecture halls. There are many products or many manufacturers who are interested to develop products, particularly for schools, because of this COVID-19 situations, where ventilating a small room where people could be studying or reading or listening any music. Ventilating plays a very important role to avoid transmission of COVID viruses. In this case, there are many products or many parameters needs to be measured apart from humidity, and one important parameter is also CO2. So the more the CO2 present in the atmosphere or the more the humidity present in the atmosphere, it could trigger an alarm that the ventilation is required right now in order to prevent the active maybe probability of transmitting virus from one person to another is quite high. As we saw, the need for the humidity sensor is very important in many different places or applications. Let's see what Würth Elektronics VSEN HIDS humidity sensor offers or solution for particular problems for indoor monitoring systems. So the Vert Elektronik Webinar HIDS is a humidity sensor with an integrated temperature sensor with a very small form factor of 2 times 2 with a width and length and a height of 0.9 mm. It is a micro sensor and also has an ASIC integrated with a particular interface to communicate to the sensor, which we will see in the coming slides. How does the sensor works? So the sensor works with a simple sensing technique. So this humidity sensor actually acts like a capacitor here, where a polymer or polymer-based sensing layer is placed between two parallel plates. When there are more humidity present in the atmosphere, this material is highly sensitive or directly proportional to the change in the humidity present in the atmosphere. Since it's a polymer, its permittivity changes due to change in the humidity. When the permittivity changes, everything else is fixed here. For example, the distance between the two plates and also the area. Only thing which could change the capacitance is the permittivity of the material. With this simple sensing technique, one could incorporate what is the humidity level present in the atmosphere from 0 to 100%. So the whole measuring range from 0 to 100% humidity will lie in form of capacitance in femtofarad. Let's understand what are the parameters this VSEN HIDS offers and how important it's for indoor air quality monitoring. As I said, the sensor could measure from a humidity of 0 to 100% with an accuracy of 3.5% in a normal humid environment from 0 to 80% relative humidity. Overall, the accuracy is plus or minus 5% from 0 to 100. It also has an integrated temperature sensor, so there is no need to have two different sensors for monitoring indoor air quality or indoor climate. Here, the temperature could measure from minus 40 to 120 with an accuracy of 1 degree Celsius in the range of 0 to 60%. Since the accuracy is mentioned from 0 to 60%, it doesn't mean it would not sense lower than 0 degree or higher than 60 degrees Celsius. It is just showing the normal indoor environment temperature range. Some of the features. So since it's a small digital sensor, the sensor could take up to 3.7 volts, so it could be easily designed with any of the available microcontrollers, and also has an SPI and I2C interface where one could talk to the sensor or put the sensor in different operating modes with these two possibilities. The sensor don't have any additional protecting layer to protect the sensing material from outside environment of dust or any other particles which could enter in the sensor. The sensor has an opening for active humidity molecules to go inside the sensor of 500 microns. In this 500 microns, there are small holes where only water molecules could go inside and not the dust particles. The sensor also has a heating function. Since, as I mentioned, there is no active membrane which protects the sensing material or sensing surface, one could think how can the sensor would work when so much condensation happens in the environment. For this particular problem, the sensor offers a possibility to heat in the entire system or entire MEMS sensor so that the condensated water molecules could evaporate and then leave within few seconds. And the sensor could give an output data is fast as up to 12 times per second with a minimum of 1 time. So every second one could read the data from the sensor or 12 times in a second. So we saw what is the need for the humidity sensor and how the humidity sensor works and what are the important parameters. And now how to handle the humidity sensor. That is also very important because of following reasons. As I said, the active sensing layer or material to sense the humidity is a plastic, a polymer. So there are certain conditions which needs to be taken care to avoid a bad performance from the sensor. So before designing the boards, one should always consider having a PCB cut or thermal cut to have an airflow, free airflow, where active sensing should happen not in the PCBs. It should happen the sensing parameter is what's outside the PCB, meaning the sensor should detect the humidity and temperature level in the atmosphere or in the air, not in the PCB. Since PCB has some copper lines or layers going around the sensor, so there will be a slight change in the temperature from the environment to the PCB. This could be avoided by having a thermal cut or by placing the sensor at the edge of the PCB. One more important consideration when we are designing the PCB with a humidity sensor or any MEMS-based sensor is to avoid a heat source placing close to the sensor. Since the humidity sensor senses a relative humidity in the environment, so the temperature should also be an important role here. So we are avoiding heating the PCB or making the PCB of 1 or 2 degrees Celsius more than the actual environment. So these are the guidelines one needs to take in care. And also one should avoid placing screws or vias very close to the sensor. This could affect, or this could create additional stress on the small thin layers for the humidity sensing, which could give you an offset of from 2% to up to 10%. As I mentioned, humidity sensor has a polymer inside, so one should also take care how to store or how to place the sensor in a controlled environment. So humidity sensor cannot be handled like any other electronic products. When the humidity sensor is taken out from its bag or MSL bag, a certain conditions needs to be maintained in terms of temperature and humidity. When the environment has a different temperature than 10 to 40 degrees Celsius, or also with a humidity of 20 to 60%, these are abnormal environment conditions, which is not good for the polymer layer. What happens if the environment is different than what's mentioned here? The sensor will have a constant offset on the positive side. Mostly after the sensor is opened, removed from the bag, it should have an offset of negative side. When we solder it, the offset should go from negative side to neutral side towards positive direction. Since to do this, one needs to also take care of the environmental parameters and what is the range. If the temperature is more or less what's mentioned here, the sensor will have a constant offset. How can we avoid this? We have to either we have possibilities of maintaining a certain temperature and humidity in the specified range, or we could follow some steps to recover the sensor performance back to the normal. Normal meaning to remove the offset. So one should put the sensor in a thermal chamber of 100 degrees Celsius for 12 hours with a relative humidity of 5%. Why these steps needs to be followed? Since the offset is telling one the layer has so much humid or water molecule present, we need to remove it. So how can we remove it is by baking. When we bake the material, so all the stuck or accumulated humidity in the layer is easily evaporated. As we can see, there is also some level of humidity is needed always in the polymer layer. We have to rehydrate it. How can we rehydrate it? By, again, placing the sensors in a temperature or humidity chamber with a certain temperature of 0 to 30 degrees Celsius and with a constant relative humidity level of 75% for 12 hours. By doing these steps, we are making the layer activated or bringing the layer to a normal condition where the offset could be minimized or offset could be completely removed. We have come to the final part. We will see what are the conclusions that we could make from this webinar. So we saw where exactly the sensing humidity is important and what are the parameters our VSEN HIDS sensor offers. Let's summarize it. So the humidity sensor has a range from 0 to 100% with an accuracy of 3.5% in the normal humidity range or normal environment of 20 to 80%. If we go below 20% or above 80%, where the accuracy could be plus or minus 5%. Similarly, for temperature could measure from minus 40 to 125 degrees Celsius with an accuracy of 1 degree Celsius in 0 to 60 degrees Celsius. So meaning the sensor would still work below 60 degrees Celsius and it will also measure below 60 degrees Celsius. Here, the accuracy is mentioned only for the environment condition for indoor monitoring. Some of the features we should take from today's webinar of VSEN HIDS sensor is the interface. So the sensor could talk to any microcontroller with I2C and SPI interface. And sensor has a protecting layer, not for condensation, only for the dust particles. To have a proper proper protection against condensation, the heating function could be implemented or heating function could be used. Okay, we have seen the parameters and the performance of the sensor. How one could evaluate the sensor's performance? We are having many options. One could use the sensor and then evaluate. Here is the best option should be using a small board where only a humidity sensor is placed. Small humidity sensor evaluation boards could be plugged to any of the system or particularly to this shield, which is called Arduino shield. So it could work with Arduino Duo and Arduino Uno. Without any soldering or cabling, one could easily plug the sensor into the system and then plug the entire system into Arduino and could directly read the humidity and temperature values. Or the second possibility is the sensor feather wing for the Adafruit feather boards. In this case, one could buy this board where all the sensors were implemented and directly plug the entire sensor feather wing to M0 Express or any of the Adafruit board which has this sensor feather wing form factor. These are the possibilities one could test the sensor performance before they're going to designing in their project. And I'm done for today's talk, and I thank you all for your attention. Now I can take the questions if you have anything.
Yeah, so thank you, Rina, for your interesting presentation. As you have mentioned, now we would like to turn our attention to your questions. So we wait a little until some questions come in. Also, the hint from my side, you will receive the link to the presentation, also to the recording of today's webinar in the next few days. We will send you an email with the links. So, Vinod, first question I can see here. Is there a protection membrane for dust?
As I mentioned before, we don't have any additional membrane for dust. The sensor is designed in such a way the water molecules should go inside, not the dust particles. So we don't have any additional like a Gore-Tex or any additional membrane to protect the sensor from dust, but the sensor is designed in such a way it is already protected from dust.
Okay, thank you for the explanation. So the next question is about the integrated heating system. How high is the current consumption of the sensor with the integrated heating on?
Mm-hmm. So the current consumption when the heater is turned off, it should be around 33 milliamps. It's quite high, but the possibility to switch it on and switch it off in order to remove the condensation, it should be very less. Meaning it could be done in 5 to 10 seconds. So depend upon how much water molecule or how humid or how condensed is the sensor. So the answer to this question is 33 milliamps. It sounds more, but the duration to turn on off time, it depends upon how much condensation happened.
Okay, so then I see one more question here. What is the current consumption of the sensor with the single shot mode?
So the current consumption of single shot mode is equal to the sensor in operation with a continuous mode of update rate 1 Hertz. So the 1 Hertz update rate when the sensor in continuous operation mode should be around 8.6 microns, which is also same for the single shot mode or one shot mode.
Okay, thank you, Vinod. Then I think we have time for one more question. Vinod, how about minimum order quantity for the sensor? Is there any limit here, or I don't know?
There is no any minimum order quantity for any of the sensor, any of the products from Würth Electronics, as long as much as how much a customer wants, one could easily order through our website. So the minimum order quantity here is like one numbers. So
Okay, thank you, Vinod. So, now I see one more question. It's also about a service topic. How about long-term availability?
So the sensor portfolio, we have a certain available time free period for each sensor. For particular humidity sensor, we have a long life longevity program, like all other manufacturers. So here, the time the sensor should available to any of the projects should be around 9 to 10 years.
Okay. So thank you, Vinod, for the explanation. And now we are finished with our webinar. If there are any questions left, you can also just send us an email after the webinar at isis-webinar@we-online.com. So thank you very much for your attention, and I hope you enjoyed our webinar. Also, many thanks to you, Vinod, for this great webinar.
Thank you so much for Marcos for hosting, and then thank you all for the listeners.
Also from my side, thank you and have a good day.
Have a
Goodbye.
good day. Bye.